Find the greatest common factor of these monomials. Now, the greatest common factor of anything is the largest factor that's divisible into both, if we're talking about just pure numbers, into both numbers, or in this case, into both monomials. Now, we have to be a little bit careful when we talk about greatest in the context of algebraic expressions like this, because it's greatest from the point of view that it includes the most factors of each of these monomials. It's not necessarily the greatest possible number, because maybe some of these variables could take on negative values. Maybe they're taking on values less than 1. So if you square it, it's actually going to become a smaller number. But I think, without getting too much into the weeds there, I think if we just kind of run through the process of it, you'll understand it a little bit better. So to find the greatest common factor, let's just essentially break down each of these numbers into what we could call their prime factorization, but it's kind of a combination of the prime factorization of the numeric parts of the number, plus essentially the factorization of the variable parts. So if we wanted to write 10, we could say, or if we were to write 10cd squared, we can rewrite that as the product of the prime factors of 10. The prime factorization of 10 is just 2 times 5. Those are both prime numbers. So 10 can be broken down as 2 times 5. C can only be broken down by c. We don't know anything else that c can be broken into. So 2 times 5 times c. But then the d squared can be rewritten as d times d. D times d. This is what I mean by writing this monomial essentially as the product of its constituents. For the numeric part of it, the constituents are the prime factors. And for the rest of it, we're just kind of expanding out the exponents. Now let's do that for 25c to the third d squared. So 25 right here, that's 5 times 5. So this is equal to 5 times 5. And then c to the third, that's times c times c times c. And then d squared times d squared. D squared is times d times d. So what's their greatest common factor in this context? Well, they both have at least 1 5. They both have at least 1 5. Then they both have at least one c over here. So let's just take up one of the c's right over there. And then they both have 2 d's. They both have 2 d's. So the greatest common factor in this context, the greatest common factor of these two monomials, is going to be the factors that they have in common. So it's going to be equal to this 5 times, we only have one c in common, times, and we have 2 d's in common, times d times d. So this is equal to 5c d squared. And so 5d squared, we can kind of view it as the greatest, but I'll put that in quotes where, depending on whether c is negative or positive and d is greater than or less than 0. But this is the greatest common factor of these two monomials. It's divisible into both of them, and it uses the most factors possible.